Hi guys, welcome to the channel Code by Raghav. In this video we are going to solve the LeetCode question number 11, that is container with most water. It is an interview very known interview question. It's a medium type question, and this question is also available in the LeetCode 75 TSS sheet. So it's the famous question and it's pretty easy. There's nothing complex here. It's a basic math. And I don't know why some YouTubers on YouTube had made this question so complex, like 1 hour to almost hour videos for this question. It's not that hard. It's very easy question. It's just a 2-3 minutes question. So it has been asked by many major companies, as you can see: Amazon, Apple, Microsoft, Google, Adobe, Oracle, Lyft, Goldman Sachs, Uber, Swiggy, Bloomberg, Atlassian, Accenture, Flipkart, Zoho, Acolyte, Infosys, many more companies, around 100 companies. So let's read the question statement and see how we can solve that. So we have given an integer array height of length n. There are n vertical lines drawn such that two endpoints of the ith line are I comma 0 and I comma height of I. Okay. Find the two lines that together with the x-axis form a container such that the container contains the most water. So we have to find two heights that can contains the maximum water means that can contains the most volume, that has the most volume between these two heights, between any two heights. And we have given this height array. This is the height of these bars, and the indexes of it is the width. So let me write the indexes: 0 1 2 3 4 5 6 7 8. So it's the index, those are the width, between distance between those bars. So we have to return a maximum amount of water a container can store. So we have to return the volume, the area. Notice that you may not slant the container. Okay. So the brute force approach is that nested loops approach, O of n square. We are not going to use that approach. It's a very bad approach. No one in the interviewer, not even the interviewer asks for the brute force approach. It's a very bad approach. So go with the optimal one. So we know we have to find the maximum amount of water can hold between any two bars. So to calculate all, use it, obviously we have to use the two pointers that we can place between these two bars, any two bars, and can find the volume or the area between the two bars. So it's obvious, we can directly see the input and the this graph. We have to use the two pointer approach, so no doubt about it. So what's the two pointer approach? We will point one pointer here. So let me take a screenshot of this graph and we will proceed it further. So here's the graph. Let me write the indexing: 0 1 2 3 4 5 6 7 8. We will place two pointers, so I will here and the j will here. Now we have to find the amount of water that can hold. It's obvious how much, if one bar is this long and this height and one bar is this height, so how much water can it can hold. It's obvious, you can show it does not hold like this. It does not hold this amount of water. It will hold the water only this minimum height level. So the to calculate the area, so we have to take the height that is of the minimum between of these two bars. So the maximum water it can hold only of this height. And the width we can calculate directly by the two pointers that we have created, the j minus I. So that's our width, that is height, this is our width. And now the point is, we have calculated the width, we have calculated the height, and we will take a current area to calculate the current area and a max area variable. Wherever see the max area, we will update our max area variable. Now the point is how we move the I and j pointers. So it's obvious, if you see, if the height of I is lower than this height of j, right? So let me write it. If height of I is smaller than height of j, so it doesn't matter you move j backwards, because currently the lowest height is of this ith pointer of ith index bar. So if you move j right over here, the area will always still the same, the max area. So you will not find the maximum area between this bar and this bar, as you can see in the example. So it doesn't matter if you move the j backwards. So max area does not have any impact on this max area. So whenever the height whose height is less than the other, we move the pointer on that verse. So here's the height of I is less than the height of j, so we'll move the I further. Else, else if the height of, let's say, I is bigger and j is smaller, so it doesn't mean ki you move this big side to this means you move the I, because the amount of water it can hold the minimum height of between the two bars. So we have already calculated this area, so we don't have to waste. So we have to calculate more options, access more options. So else whenever the height of j is less, we will j will move backwards. And the one more case, that is height of the both bars is same. No matter what your pointer moves, it will give the same result. So that's the approach. It's a basic simple approach, and for the area we already know is the width into height to find the volume or the area. So that's the formula, that's the basic maths, 8th class maths, not even 8th. So let's try to solve it quickly and see. So first we have to calculate the n is of height dot size. Let's take two pointers I 0 and j will start from n minus 1, and take a max area variable. Let's initialize with 0, and while let me return the max area, while I is less than j. Why I less than j? Because let's say your I and j meets here, I is less than j. This is your condition. So if it I goes backward and j goes backward and I goes, it's the same Same area, just the values are different, just the indexes are different, but it will cause the same area. You 1 into 2 is 2, and 2 is 1 is still 2. And we are not doing the I less than equal to j, because if you do that, mm, let's say I and j here together, so it means there's no water, there's only this single bar, so the obviously the area will be 0. So it's, so put the equal to marks is of no use. Let's calculate the width is j minus I. Let's calculate it. The height is of what? It will be the minimum of between two bars, because the amount of water is only the minimum height of water it can hold between these two bars. If you put more water, then it will spill it out. And minimum of height I and height of j, and let's calculate the current area, width into height. Let's update our max area, max area, current area. Now how we move our pointers. So if the height of I is less than height of j, so moving j backwards is of no use, because the height of I is already low, so it will hold the amount, only that amount of water. So we will move the I forward, else j plus plus. Let's try to run it. Sorry, not j plus plus, it will be the j minus minus. Let's try to run it, and it will be the width, not w. And the example test cases are passed. Let's try to submit it. To check all the test cases, we have successfully accepted the solution. Let me, so we are running I less than j. On the worst case, it will move forward, it will iterate over the array O of n times. We are not using any extra space, so space complexity is O of 1. This is our time, this is your space. So that's it for the video. Thank you for watching.